So in the last lecture, we have discussed the primary factors, how it affects the rate of corrosion, and we talked about all these four factors which are responsible for affecting the rate of corrosion. Now coming to the secondary factors, and we'll be discussing about all those five secondary factors which are responsible for the corrosion, right? Okay, so the first is pH. So the effect of pH is totally different on different metals, but we'll be talking about just iron because iron is something which we use more in our daily life, and we see the rusting of iron very often. We already see. So in case of iron, rate of corrosion or rate of rusting of iron increases when we increases the acid content. Means if the pH decreases, the rate of corrosion of iron increases, right? So this is how pH affects the iron. Simply we can say when pH decreases, rusting of iron increases. Second point is temperature. So we already know rate of corrosion is generally slow because it already have some activation energy. So as we increase the temperature, so some of the molecules of iron get excited, and that leads to more and more corrosion, right? Third point we'll discuss in the last. So next is conductance of a medium. How conductance of medium affects the rate of corrosion? Because we know corrosion is just like a cell. It's just like a corrosion cell where we have anode, cathode, and electrolyte. So when we increase the conductivity of the electrolyte in cell, we already know the EMF increases. So same thing happens here also. When we have more and more conductance of the medium, that is only possible by dissolving more and more electrolytes in the water. This will lead to more and more faster corrosion. Last is humidity. Humidity means more and more moisture content, so that will lead to the wet corrosion. And we already know wet corrosion is faster than that of the dry corrosion. So that's why we said a metal will corrode faster in Mumbai than that of Delhi. Now this point, anodic upon cathodic area effect. For this, again, we'll have to bring the concept of, or we'll have to recall the concept of concentration cell. And in concentration cell, we already know the EMF is going to be positive only when cathodic concentration is more than that of the anodic concentration. It means if cathodic area is higher than that of the anodic area, so cathodic area will be exposed to more and more electrolyte, and anodic area will expose to less and less electrolyte. So in that case, the corrosion is going to be feasible. So we can say when anodic area, which should be less, and cathodic area, which must be higher. So we can say anodic area upon cathodic area must be less, so that we can have more and more corrosion. So using this concept, we can say galvanized iron is better than tin. And why it is so, that we'll discuss in detail in the next lecture. Thank you.